Alright, welcome to 13.2, Angles and Radians. In this lesson, I'm going to introduce to you what a radian measurement is for the first time. We're also going to graph angles, and we're going to find something called coterminal angles, and we're going to graph in radians also. There's a lot of new content in this lesson, so if you're here watching this on your own, make sure that you write down questions and talk to me in class if you need anything clarified. So first of all, we're going to start by drawing some angles, and remember, an angle is formed by two rays that have a common endpoint called a vertex. And here's what I do with my rays. One of them is going to start on the positive x-axis, and the other one is going to go somewhere into one of the quadrants, and this is called standard position. So standard position happens when the vertex is at the origin. The initial side, which is the starting side, is on the positive x-axis. They mean right here. So that is always where the initial side is going to go for your angle you're drawing. And then the terminal side is the ending side. It may be located in any of the four quadrants. For an example, I'll put it over here. But it could land anywhere. So that is called the terminal side. Here's a few things that are new to you. First of all, in my XY coordinate plane, we're going to give this rotational direction. And so here's what I mean. The initial side starts at 0 degrees. You know that one full revolution is a 360-degree turnabout, right? So if you do a 360, it means you did one revolution. So based off of that, half a revolution is 180 degrees, and a quarter of the way would be 90 degrees. 3/4 of the way would be 270 degrees. Write those down carefully. So my four axes, I guess I could call them, go from 0, 90, 180, 270, 360. But as you know, it is possible to go more than 360 degrees. So if you need to go more than 360 degrees, each quarter of a circle is just 90 degrees more. So 360 plus 90 would be 450. What that means is an angle that's 90 degrees and an angle that's 450 degrees would land in the same spot. If I add 90 again, I get 540 degrees here. If I add 90 again, I get 630 degrees. And I could keep going infinitely, actually. Now, we are also going to go negative. So what I was just doing here with the positive angles, did you see I was rotating? Hopefully you can see my pen going like this. I was going in a counterclockwise direction, actually. And so always, I'll write it down here, a positive angle is going to be rotating in the counterclockwise direction. A negative angle goes the other way then. So a negative angle goes in the clockwise direction. Which means I'd start here, but I'd go down here first. So this is also negative 90 degrees. And then notice all three of these are all 360 degrees apart from each other. If I just add 360, I get 270 plus 360. So they're one revolution away from each other. If I add another negative 90, this spot right here could also be negative 180 degrees. Add another negative 90, so this spot up here could also be negative 270. And I could keep going infinitely. Add a 90 and I get negative 360. And now you're going to need to know something about quadrants here. So just a quick review, quadrant 1 starts right here in the upper right hand corner, and then it goes in a counterclockwise direction. So quadrant 2 is up here, quadrant 3 is down here, and quadrant 4 down here. Last but not least, you see how I could go with my angle? You don't know right now if I rotated clockwise to get there or if I rotated counterclockwise to get there. So you always, when you're doing these, need to show a directional arrow that shows which direction I rotated. And you need to have that directional arrow when you're graphing these to get full credit. Now, whenever I'm going to actually graph an angle, starting with example B, I recommend you write down your 4 key points here. And those you have to have memorized. So again, I would recommend every single time write those down. I actually have an angle that's 400 though, so I'm going to have to keep going. So I'll go to 360, I'll add another 90, I get to 450. Alright, wait a second. So I know 400, it has to be between 360 and 450, so I know it's in quadrant 1. I don't think you're going to be perfect with these, and I'm not expecting you to be, so just kind of draw it in there. Just make sure when you do your directional arrow, so I went one full rotation and then another little bit to go there, and that is a 400-degree angle. So I have my directional arrow, I label it. They also this time asked me to state which quadrant it landed in. It landed in quadrant 1. Alright, let's look at C. Since this one is going negative, let's do my labels for my negative direction. So 0, negative 90, negative 180, negative 270. But I don't really need all those because negative 45 has to be between 0 and negative 90. Actually, negative 45 is exactly halfway, so I'm going to do my best to draw the halfway ray there. I'm going to show my directional arrow, label it, and then they again wanted to know what quadrant that ended in, so that ended in quadrant 4. So that is me drawing my angle. So when you're doing this in your homework, you're just going to make a little sketch and draw it, labeling the angles. It doesn't have to look super nice, and I don't have any graph paper or anything for this. Let's keep going. Alright, so again, label your key points here. And if I do that, I can see that 210, that's going to go somewhere in between 180 and 270. And it seems to me that it's a little closer to 180. So I'm going to do my best to draw a little closer to 180. Then I draw in my directional angle and I label it 210 degrees. That one ended in quadrant 3. Alright, when I have something that has a lot of rotations, like I said before, you can just keep adding or subtracting 90 degrees every single time to figure out what your labels are. So I have my standard ones labeled for my negative direction. Now I'm going to continue adding a negative 90 degrees with each line I get to. So this would be negative 360 degrees, this one would be negative 450 degrees, this one would be negative 540 degrees, and then I can stop because it's less than negative 540 degrees, or I guess greater than negative 540 degrees, if you want to think of it that way. Anyways, it's going to land in here. And again, it looks like it's a lot closer to this one than this one. It's closer to negative 540 than negative 450. Now, I rotated in the negative direction, and I did a full rotation plus some. And that, again, landed in quadrant 3. Why don't you pause the video and try F on your own, and then when you unpause, I'll have the answer showing. Alright, check to see how you did for F. My ending ray got a little thick there. I kind of messed up a little bit. Alright, so that was graphing angles and standard position. The next concept I'm going to teach you about in this video is something called coterminal angles. So, did you see how with my angle rotation, you know how these could be labeled with several different things? Because if I kept rotating and rotating and rotating, I could land in the same spot a bunch of different times. I'm just adding and subtracting rotations. Well, if I've got two angles that land in the same spot, but they have different measurements, those are called coterminal. And now here's the official definition. It's two angles in standard position, two angles in standard position whose terminal sides coincide, which means they land in the same spot. So in regular terms, two angles in standard position whose terminal sides coincide, but in regular terms, just your angle ends in the same spot but has a different measurement, potentially. Actually, if it is the exact same angle, it is also considered coterminal. But ends in the same place, has a different measurement, potentially. And to do this, we add and subtract rotations. And when I am in degree measurement, one rotation is 360 degrees. So when I'm in degree measurement, adding and subtracting revolutions or rotations is just adding and subtracting 360. So let's go for it. And you always do it from your original angle. So it says, for example, 2, find one positive and one negative coterminal angle for each of the following. Add 360, which would be 300. So that gives me a positive coterminal angle. So I just added a revolution. Now I'm going to take negative 60 and I am going to subtract 360. And I get negative 420. So that's the negative angle. So those are both coterminal. One of them's positive, one of them's negative. Again, just add 360 or subtract 360. So add 360. Example B, I get 260 degrees. Take negative 100 and subtract 360, and I get negative 460 degrees. Now, comment for example C. Sometimes when you subtract, let's say right now that I added 360, I could get a coterminal angle, which is 575 plus 360, so that would be 935 degrees. But it actually turns out that if I subtract 360 from 575, 575 is such a big number that I still end up in the positive zone. So there's an infinite amount of positive coterminal angles I could find, because you just keep adding 360. But either of these would be a correct answer for the positive coterminal angle. Now the thing is, I haven't found my negative one yet, so I actually have to subtract 360 again, and I get negative 145 degrees for my negative one. I hope you have the hang of it. We're going to just skip D, because this is going to be a long video anyways, so feel free to try it if you want. Here's a potential answer. Positive 385, negative 335. Now, the last part of example 2 we're going to come back to once we have learned about something called radian measurement, because all of those are in radians. So if you're ready, go ahead and flip to the back. So, I mentioned this in section 13.1, but we have 2 different units of measurement to measure angles. It's just like how for distance you could measure in feet, miles, or you could measure it in meters, kilometers. So there's 2 kind of totally different measurement systems, right? We could convert between the 2 systems, and I'm sure you've done that a lot in science class, but 2 totally different measurement systems. Same thing with angles. There's the degree measurement system, which is what you are familiar with from your past, and then there's something that I'm going to teach you right now called the radian measurement system. So this is brand new, but very commonly used in trigonometry and calculus, pre-calc, for those of you going on. So radian measurement, the formal definition of it is the measure of an angle and standard position whose terminal side, so the ending side, intercepts an arc of length r. But here's my informal definition. We're going to take something called the unit circle. A unit circle has a radius that is equal to 1. So my radius of my circle is equal to 1. And here's what's happening. I'm going to find the circumference of this circle right now. Remember the circumference formula for a circle back from middle school is 2 pi r? Well, my radius is 1, so my circumference is 2 pi times 1, which is just 2 pi. What we're going to do is we're going to have 2 pi, which is actually the measurement around the edge of the circle. That's going to represent my radian measurement of an angle, and 2 pi is going to then represent 1 full revolution. So here's what I want to tell you, side note then. A radian measurement, basically, it's measuring the distance along the edge of the circle. And it's measuring the distance along the edge of a circle with radius 1. So the radians are basically measuring the distance along the edge of a circle with radius 1. So that's where it comes from. Now, if you don't really understand how that comes about, you can still use it very easily. Or, like, well, actually, I shouldn't say very easily. It is kind of tricky, but you can still use it if you don't understand where it comes from. What you just need to know is, so 1 full revolution in radians is 2 pi. In degrees, it was 360 degrees. So that means that 1 full circle is 2 pi radians. So that means a half circle, which is 180 degrees, would be 1 pi. A quarter circle, which is 90 degrees, would be half of a pi. So that's how that kind of translates. And if I look at my circle here, my radian measurement would start here at 0, just like the degree starts at 0. So at 90 degrees, it's pi over 2 radians. At 180 degrees, it's pi. At 370, it's 3 pi over 2. And at 360, it's 2 pi again. Something that we're going to do today to start off with is just convert between degrees and radians. So here are some formulas for converting. If I want degrees, here's what I'm going to do. I'm going to take the radians that I was given, and I'm going to multiply by 180 over pi. Notice, this is just like a conversion formula like you would do in science class, you know, like 60 seconds over 1 hour or something like that. Remember that from science class? It's just a conversion factor. And I could have done 360 over 2 pi. I just didn't because 360 and 2 reduces to 180. So I'm just using the half circle instead of the full circle. And then the other formula is, if you want a radian measurement, I'm going to take the degree measurement that was given to me, and I'm going to multiply by pi over 180. So I just flip it, just like you did back in science class with other conversions. All right, so, and I want to tell you that you are going to be expected to do some of these without a calculator. So, and it will be the easier ones, but I want to tell you, don't right away jump into using your calculator. Try it without first in every situation, and you'll find a lot of them are actually easier than you might think. So the first one I was given degrees, so that means I want to find radians. So my radians is equal to my degrees times pi over 180. And here's where I mean this is easier than you might think. Remember, if I have something on top and something on bottom, I can basically divide by 10, which immediately cancels out the zeros. So now I have 14 pi over 18, and I know both of those can be divided by 2 because they're both even numbers. 14 divided by 2 is 7. 18 divided by 2 is 9. There I have my answer immediately without even pulling out my calculator. So that is the kind of thing you would be expected to do on your page. Those ones that will be rather easy. Now let's do a few more just so you can get the hang of it. And I'm going to go kind of fast, so make sure you pause the video if you need to. So again, I want radians, so I'm given degrees, and I'm trying to get radians, so here I go. 200 times pi over 180. Once again, one of the zeros can cancel with each other, and now I have 20 over 18. Divide by 2, 10 pi over 9 radians. Alright, here's another one, 330 degrees. So 330 times pi over 180, cancel out the zeros. Now this one's a little less obvious, but 33 and 18 can both be divided by 3. 33 divided by 3 is 11. 18 divided by 3 is 6, so 11 pi over 6 radians. And now let me show you something with 225. When I look at 225, this is where some students kind of break down and they're like, I can't do this in my head. You could divide both of them by 5, and you might have to do side old school division to figure it out if you had to do it by hand. But let's say I did want to use my calculator. When I'm going to type this in, I want my answer to have a pi in it, so do not use the pi when you type this into your calculator. Just type in 225 divided by 180, and then you can use your math fraction button to reduce it for you. And there I go. Alright, let's go the other way. So now I'm given radians, I want degrees. So I want a degree measurement, so I take my radians times 180 over pi. And here's how I'm going to do these ones without a calculator. First of all, I know the pi cancels each other because pi over pi is 1. And then in my mind, think about it. If you're not sure what 180 divided by 3 is, think 18 divided by 3. You all know 18 divided by 3 is 6, right? but just put the 0 on. So 180 divided by 3 is 60, with no remainder on bottom. And then 2 times 60 is 120. Let's do another one. 8 pi over 11 times 180 over pi. And now this one, the pi's cancel, nothing else cancels. So here's where maybe I'm going to use my calculator. This is one that's harder than what you would see, what you would have to do by hand. So I'm just going to type in my 8 times 180 and then divide by 11. But, oops. So 1440 divided by 11. But again, we want it in the lowest reduced fraction form, which in this case is just 1440 over 11. All right. Why don't you pause and try G and H and see if you can do them, and then when you unpause, I'll have the answers showing. All right, so here you are. G was 140 degrees and H was 585 divided by 2 degrees. Moving right along, we're now going to do everything we did earlier, only in radians. So we're going to graph in radians. We are going to find coterminal angles in radians, and I'm also going to show you how to use radians in your calculator. Right now our calculators are in degree mode. So I'm going to draw an angle, and I want to tell you that we are going to have to convert a lot of fractions here. And if you are someone who really struggles with converting fractions, for that reason alone, you might find this confusing. So feel free to go back and replay a video if you need to. I would recommend, for example, if A didn't make sense the first time, replay example 4A once or twice if needed. Now, here's the deal. I'm supposed to graph 5 pi over 7. You might first approach that and be like, wow, I have no idea what to do. Well, remember up top, I gave you the standard, kind of like I had 0, 90, 180. Here's kind of my standard set of labels. And I need to figure out where 5 pi over 7 fits in here. I can't figure that out unless I have a fraction with a common denominator. So I need to make all of these a common denominator. And when I look at something like pi over 2, well, right now I guess I've got 7 and 2 on bottom. So the easiest common denominator I could think of would be 14, 7 times 2. So for example A, I'm going to convert my denominators to 14. Now for the fraction I'm given here, to convert it to a 14 on bottom, I'm going to times by 2 over 2. So that's 10 pi over 14. But for each one of these, it's going to be slightly different depending on what I'm given. So for this first one, again, I want it to be a 14 on bottom. So think to yourself, what do I need to multiply on top and bottom to make it 14? Well, it's 7. So that one's 7 pi over 14. Now for this one, to make it a 14 on bottom, right now it's a 1 on bottom. So I'm going to multiply by 14. Now that kind of makes sense if you think about it, right? Because 14 over 14 is 1, so 1 pi. And I could keep going if I need to, but I can stop right now because I have 7 pi over 14 and 14 pi over 14. My original thing I'm graphing is 10 pi over 14. 10 is between 7 and 14. So I know it has to be in this quadrant here, quadrant 2. I don't need to keep converting these other ones because I'm done. I know it's going to be in this quadrant. So again, initial side starts there, and then my terminal side is here because I have a common fraction denominator, so I can compare these, and 10 pi over 14 is between 7 and 14 pi over 14. And then when I label it, I'll put the original one though down, but there's my graph. And again, maybe I'm not sure exactly where 10 pi over 14 is, but as long as I have it in the correct quadrant, I'm happy with that. For example B, I'm going negative, so I didn't say this earlier, but just like how it goes 0, 90, 180, but to go negative 0, negative 90, negative 180, it kind of goes the opposite way. This also does. So over down here would be negative pi over 2. This would be negative pi. This would be negative 3 pi over 2 if I made them all negatives. Now, every single time I graph one of these, I'm going to need a different common denominator. This time, I've got a 5 on bottom here, so between 5 and 2, my best common denominator would be 10. So this time, I'm going to convert them all so they have a 10 on bottom. So to make this one so it has a 10 on bottom, I'm going to multiply by 2 over 2, so I get negative 16 pi over 10. Now when I try to convert these, again I want a 10 on bottom. So for this one, multiply by 5 over 5 to make it a 10 on bottom. Now that's way too small because I'm looking for negative 16 pi. So this one I'll multiply by 10 over 10. I have to keep going because that's too big still. So multiply by 5 over 5. That one, 3 times 5 is negative 15 pi. And just to show you something here, if I was going to do this one, I would get negative 20 pi over 10 for 0 degrees or 0 radians. So this goes between these ones in quadrant 1, and it's going to be closer to 15 pi over 10 than it is to the negative 20 pi over 10. Again, seriously, you might need to go back and watch those two examples a few more times to get the hang of it. Example C, I want to tell you that this is pretty difficult. I would recommend that if you're someone right now who you weren't in class, so you didn't get the notes, you're doing this on your own, circle that one and ask me about that one, because basically 40 pi over 3, well, 1 revolution would be 6 pi's over 3, so I'm going to need to subtract revolutions a bunch of times in order to figure out where I'm going to graph this, and that's kind of tricky, takes a while. So why don't you skip that one for now and ask me about that in class. I've got 2 more things I need to show you before the end of this video. First of all, I need to show you how to use radians in your calculator, and then we're going to flip back to the front side and do the finding the coterminal angles. So now, to evaluate these in your calculator, I can just type them in as normal once I'm in radian mode. Once you are in radian mode, just type them in. And now review from 13.1. If you don't remember how to change your calculator mode, the mode key is right here, right next to the second key. And just make note in your mind that you're in radian mode right now, so that when you go back and try to do other problems from 13.1, you don't get the wrong answer. But okay, I'm in radian mode. Once I'm in radian mode, I can literally just type them right in. So sine of 3 pi over 7 is 0.975. I just need to make sure I round correctly. Cosine of 6 pi over 5 is negative 0.809. And tangent of 11 pi over 9 is 0.839. So that's easy, just again, you got to make sure you're in the right mode. Flip back to the front. We're going to finish those finding a coterminal angle. Now remember how I said finding a coterminal angle is adding or subtracting rotations. So if I'm in degree measurement, that meant 360 degrees. Now if I'm in radian measurement, 2 pi is 1 rotation. Remember, 2 pi is 1 rotation or 1 revolution. So in order to figure out a coterminal angle, I'm going to add and subtract 2 pi. And again, here's where common denominator comes in. If I'm going to add 2 pi to this, I can't right now. They don't have a common denominator. Luckily, I can make a common denominator of 3. So multiply top and bottom by 3 here. So 2 pi is the same thing as 6 pi over 3. And then if it's just pi, it's like 1. So 1 pi over 3 plus 6 pi's over 3 is 7 pi's over 3 for my positive coterminal angle. And then I'm going to do the same thing, only subtract. So pi over 3, subtract 2 pi. And now be smart here. You already figured out that 2 pi is 6 pi over 3, so let's just write 6 pi over 3 here right away. Okay, so it's like 1 pi over 3 subtract 6, which is negative 5 pi over 3. Sometimes they make your life easy, like example F. So here, when I try to add 2 pi, it already has a common denominator. They're both over 1 essentially, so I can just add them. 3 plus 2 is 5. Yay, 5 pi. And then if I want to find my negative one, I'll subtract 2 pi. Well, I need a negative 1, so I need to subtract 2 pi twice in order to get there. 1 pi subtract 2 pi is negative 1 pi. So there I go for that one. Look at G. So again, I'm going to try to add 2 pi, but I don't have a common denominator because that one's a 9. So I'm going to multiply this by 9 over 9. So 18 pi over 9 is the same thing as 2 pi. And then 4 plus 18 is 22. So 22 pi over 9 is my positive coterminal angle. Again, I don't have to refine this. I already know 2 pi is 18 pi over 9, so I'll just subtract to find my negative 1. 4 minus 18 is negative 14 pi over 9 for my negative 1. And H is another easy one. Just add 2 pi. If I add 2 pi, I get my negative 1 right away. So keep adding 2 pi. Keep adding 2 pi. My positive 1 is pi. Thanks for listening. Make sure you write down any questions you have, and we'll talk to you again soon.